Hi all, we'll be talking in these segments about solubility and equilibria for things that are soluble or slightly soluble in water. So let me go to the lecture objectives for this first segment. And so we'll be looking at understanding solubility equilibria within the context of solution reaction equilibria in general. Particularly we'll be calculating the KSCP of compounds given equilibrium concentrations. And then the flip side, calculating the solubility of a compound given its KSP. So solubility equilibria, it's just another type of reaction equilibria. So the same sorts of reaction equilibria we've been seeing for a while. So in this case, we have calcium fluoride. Well, the reaction there is the dissolution of calcium fluoride into calcium 2 plus and 2 ions of fluorine. So if this is just a reaction equilibrium, so KSP is really just a form of Kc. It's just another Kc. And in this case, the reactants are calcium ion and then fluorine ion squared because there's two of them. The calcium fluoride, of course, doesn't appear because it's not in the solution phase. So it's just a pure compound, and so we don't include that. It's already at its standard state, so we don't need to include it in the KSP. And so KSP, it's the solubility product constant or solubility product. Again, it's just a Kc. It's a Kc for something that is usually sparingly soluble. Yes, remember all the Kcs are equilibrium constants of specific reactions. The KSP is the reaction of an ionic solid dissolving into water. Yep. So, so let's see. So if the concentrations of calcium 2 plus and fluorine minus in a saturated solution of calcium fluoride are known, then KSP can be calculated. Now, you need to have a saturated solution. If it's less than a saturated solution, then the reaction is going to be entirely in the product. So the equilibrium would be not toward to just having everything in a solution, not in a solid. So if you have a saturated solution, then you know it's an equilibrium between the solid that's precipitated out and the concentrations that are above. So you need to be looking at this in a saturated solution, meaning there's some calcium fluoride present. Otherwise, the reaction is not going to happen. Okay, so we have calcium 2 plus and fluorine minus. So the KSP is simply going to be is equal to the calcium concentration times the fluorine concentration squared. And so adding these in, we just get 1.5 times 10 to the minus 10th. So that would be the KSP of calcium fluoride. Obviously, this is a reaction that is not going strongly forward. Calcium fluoride is mostly insoluble, but nothing is totally insoluble. You can always you always have an equilibrium with some amount present in solution. But when we talk about something being insoluble, it means a very, very small amount, within rounding, 1 part in 1,000 is dissolved and the rest is formed precipitate. We usually talk about things that are soluble where we can put, a huge amount, up, a third or a fourth of the amount of solvent that's there. When something is soluble, we usually talk about being able to put 20 grams or 30 grams per 100 grams of water. So essentially we're adding as much as we can until the ions are completely surrounded by water, and you just run out of water to surround the ions. These are different. We would call them generally insoluble, which means almost all of it is in precipitate, but there's still going to be some concentration in the solution. Okay, so that's KSP. And one important thing is, what about the units? Remember that these are all units, these are all divided by 4 times 10 to the minus 4th molar divided by 1 molar. So everything, it's not actually a concentration, it's a concentration reference to the standard state concentration, which is 1 molar. Okay, so next we can look at solubility. So let's calculate the molar solubility of magnesium fluoride in water at 25 degrees C, given the KSP. Again, we can tell that there's not going to be that much in solution, but there'll be some because KSP is quite a small number, so it's not going very far towards products. Okay, so the way we do this, we set up an ice table. But these ice tables are actually a little bit easier than with acid-base reactions. So ice. So when we start, we have the only two things that appear in the equation are magnesium and fluoride. And so initially there's no magnesium, no fluoride, we just would have solid magnesium there. So this is imagining what we do if we drop magnesium fluoride in and saw what would happen. So the change, well, there's going to be plus X of magnesium and plus 2X of fluoride. Every single magnesium releases 2 fluoride. So, and then, at equilibrium, that's just going to be what it is. It's just X of magnesium and X of magnesium and 2X of fluoride ion. So we have the KSP is equal to X times 2X squared equals 7.4 times 10 to the minus 11. And so that is 4X cubed, and that equals 7.4 times 10 to the minus 11. And this is actually relatively easy to solve. This is not, although, yes, it's got an X cubed in it, it's not a cubic equation. There's no quadratic or linear term. So we can just divide by 4 and take the cube root. And what we get out is X equals 2.6 times 10 to the minus 4. So if you put magnesium fluoride in water, you will get a small amount of magnesium fluoride out. How much? Well, the concentration of magnesium will just be that. The concentration of fluoride ions is going to be 2 times X. So it'll be 5.2 times 10 to the minus 4 molar. Okay. So that is how you can calculate the molar solubility.